Okay, so today we're on page 303 and we are going to be proving triangles congruent. Proving triangles congruent using ASA, which is angle side angle, and AAS, which is angle side. So angle side angle and angle side. And we're going to say that an included side is between two congruent angles. All right, an included side. This S in angle side angle is between, the S is in the middle of the acronym. And if it's in the middle of the acronym, it means it's got to be touching the two congruent angles. So the angle side angle postulate states that if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle then the triangles are congruent. All right, angle side angle. An angle included side and an angle of one triangle congruent to two sides and the included angle of another triangle and the included side of another triangle, then the triangles are congruent. So there's a bow tie there on page 303. And we've got triangle ABC and triangle CDE. Now, you're told or you're given that angle A is congruent to angle E, and that BD bisects AE. Now, your directions in your practice problems today will say, prove the triangles are congruent, what I want you to do is just determine if the triangles are congruent, write a congruent statement, and explain, which is what you did yesterday. So, based on the information given, angle A is congruent to angle E. Now, this right here is really important. BD bisects AE. So from B to D, this whole piece right here bisects A to E. So if BD bisects AE, it cuts it in half. So this piece AC is congruent to CE. And that comes from this given information that BD bisects AE. Now, again, in this bow tie where two lines or two segments intersect each other, you've got vertical angles. And these two angles here are congruent to each other. So we've got an angle, side angle, and an angle, side angle. And the side is touching both of the angles. So you've got an angle, side angle relationship. So are the triangles congruent? You can say yes. Then we're going to write a congruent statement. Triangle. I'm going to start up here at A, and I'm going to call the triangle on the left ACB. ACB is congruent to triangle. Now, if we started with A on the left, what do we start with on the right? E. And we go to C, and then D. All right, so yes, they're congruent. Triangle ACB is congruent to triangle ECD, and we're going to say by angle, side angle. Everybody okay with that? All right. Take that as a yes. Look down at the bottom of page 303. And we've got this picture here. W, X, Y, and Z. And then we got a segment that goes from Z to X. Now, here's what you're given. That WX, let's see, WX is parallel to YZ. And WZ is parallel to YX. All right, so WX is the top, it's parallel to YZ, which is the bottom. So the top's parallel to the bottom. WZ, which is the left side, is parallel to YX, which is the right side. So left side's parallel to the right side. Now, if you have two pairs of parallel lines, the horizontal lines are parallel and the vertical lines are parallel, that makes Z to X a transversal. All right? And if a transversal cuts two parallel lines, then these angles in here, this angle right here, is congruent to this angle down here. And that's by alternate interior angles. And then the other pair of alternate interior angles are congruent. So this angle is congruent to this angle. And then we've got a triangle here on the top left and a triangle on the bottom right. Don't they share a side? They both share side ZX. Agreed? So this triangle, or this side, is the same in both triangles. So we've got an angle. I'm looking at this bottom triangle. We've got an angle, an included side, and an angle, congruent to an angle, an included side, and an angle. All right, so it meets the criteria. Are the triangles congruent? Yes. I'm going to name the triangle on the top left. I'm going to call it XZW. And it's congruent to triangle. If I started with X up here, which vertex do we start the second description with? Start with Z. And we go across the congruent side, so ZXY. And that is by angle, side, angle. All right, to meet angle, side, angle criteria, you have to have an angle, the side in between, and another angle congruent to an angle, side in between, and another angle. All right, so let's look at one case. If we do a triangle here on the left, and then a triangle on the right, and this is just going to be an example of when you can't use angle, side, angle. So let's say in the triangle on the left, we get an angle, a side, and an angle. And in the triangle on the right, we go angle, angle, and then a side. Okay? So on the left-hand side, we get angle, side, angle. That works. But on the right-hand side, do you see how the congruent side is not touching both of the angles? Okay? So in this case, right now, you can't use angle, side, angle. All right? If I label this triangle on the right NMO, which side in the triangle on the right needs to be congruent to the side on the triangle on the left in order to use angle, side, angle? NM, right? N to M would have to be the congruent side in the triangle on the right in order to use angle, side, angle. So just make sure you understand the difference. This non-included side, all right, doesn't allow you to use angle, side, angle there. All right, look at page 305 up on top, and we're going to cover one more theorem. And angle, angle, side congruence. So this is AAS. And angle, angle, side states that if two angles and the non-included side of one triangle are congruent to two angles and the non-included side, of another triangle, then the triangles are congruent. If two angles in the non-included side of one triangle are congruent to two angles in the non-included side of another triangle, then the triangles are congruent. And if you look at the acronym, the S, which represents side, is sitting out here by itself. Okay, it goes angle, then an angle, and then a side. So the S is not in between the angles, so that's called a non-included side. So again, there on page 303 up top, you got two triangles. Triangle ABC again, and triangle DEF. Angle A is congruent to angle D. Angle B is congruent to angle E. And BC is congruent to EF. All right, B to C is congruent to E to F. All right, so starting with angle A here, I can go clockwise around this triangle, angle, angle, side, congruent to, starting at angle D, I can go counterclockwise, angle, angle, side. All right, so we've got an angle, and a non-included side congruent to an angle, angle, and non-included side. So are they congruent? Yes. Triangle CBA is congruent to triangle. If we went C to B, what do we start the second description with? F to FED. All right, so yes, the triangles are congruent by angle, angle, side. Any questions there? You have questions? All righty. Let's do one more. I saw that. Ooh. All right, we got LMN, SRQ, and let's say that an angle, and the side. All right, so L is congruent to Q, M is congruent to R. Now, what if QR is the congruent side on the right? Now, are the triangles congruent? Can't use angle, angle, side, can you? Okay, so we're going to say no. And in order to use angle, angle, side, we can say that which side needed to be congruent to MN? RS, right? No, we're going to say that RS must be congruent to MN. All right, so no, they're not congruent, and that's the reason why. All right, so again, the directions are going to ask you to rate each proof today, but I don't want you to write a proof. I just want you to write congruent statements and give me a reason why. All right, whether they're congruent or not, you're going to give a reason. So your practice is going to be on page, going to start on page 307, 1 through 4, and then on page 309, 12 through 15. All right, and again, you got 10 ALEKS topics.